Today we are going to review some u substitution problems. So whenever we're doing the u substitution, our goal is to have the u function whose derivative is sitting next to it. So we want to call our function u whose derivative we can see in the function. So usually something to the power n, that will be our u, or 1 over something to the power n, that something will be the u. The longer x expression will be the u. Our inside function will be the u. Square root of something, that something will be the u. 1 over square root of something, that will be the u. Or e to some power, that will be the u function. Let's look at a couple of examples of u substitution. Here's first example, integral of 2x times x squared plus 1 to the 4th power dx. So we are going to let x squared plus 1 as u because I see its derivative sitting out in the front. So 2x dx will be du. If I differentiate with respect to x, then 2x will be equal to du over dx, or I can say 2x dx is du. So I can see over here the remaining expression will be my du. So if I write this integral in the terms of u, so I will have u du, u to the 4th power du, and the integral will be u to the 5th over 5 plus c. Don't forget it's an indefinite integral. I must add a c over there. And now I'm going to replace the u by whatever we call u in the beginning, and that's our integral. Let's see a couple more examples. Here we have secant square x, tangent x. So in this case, my u will be, u is something whose derivative is sitting next to it. So u is tangent x, du dx. When I do the derivative with respect to x, that will be, this was tangent x. When I do the derivative with respect to x, that would be secant square x. And I can say du is secant square x dx. So this expression is du and this is my u. So when I write this integral as in terms of u, this would be u du, which is u squared over 2 plus c, and that's going to be tangent x squared divided by 2 plus c. All right, another example. Here we have 2x squared square root of x cubed plus 2 dx. So I'm going to let x cubed plus 2 as u. 3x squared, when I do the derivative with respect to x, it would be 3x squared is du dx. And I can say 3x squared dx is du. I don't need 3x squared. I actually need only x squared dx. So I'm going to say x squared dx is 1/3 of du. Now I'm ready to write this integral in terms of u. I'm going to leave the 2 over here, so 2 in the front, and 1/3, and we have du and square root of u. So 2/3 can come out in the front, and when I do the integral of square root of u, that would be u to the power 3/2 divided by 3/2, which is same thing as multiplying by 2/3, because 1/2 plus 1 is 3 over 2. Okay, and that's going to be 2/3 times 2/3, that would be 4 over 9. And instead of u, I'm going to replace it with whatever we call u in the beginning. U was x to the 3rd plus 2, x to the 3rd plus 2, raised to the power 3/2 plus a c. Okay, if we are looking at a definite integral, then we must change the bounds as well if we are keeping the integral in the u form, or if we want to not change the bounds, then we want to replace everything in terms of x at the end before we substitute the bounds. Okay, example number 7 is what we're going to look at next. 2 secant square x tangent x plus 3. So I'm going to let tan x plus 3 as u here. So secant square x will be du dx, and secant square x dx is du. So secant square x dx is du, and this is my u, and I'm just going to pull the 2 out. It's a constant. So this integral in terms of u would be u du, which is 2u squared over 2 plus c, and we can cancel the 2 and 2. tangent x plus 3 squared plus a c is what we're left with. Right, couple more examples. Here we have x over square root of x plus 1. So how are we going to evaluate this? What's the derivative of x plus 1? It is not, it's 1, but, or 1 dx. If I differentiate with respect to x, I wouldn't have that sitting on the top. So I got to be a little clever here. So I'm going to go ahead and let x plus 1 be the u, and that would be du over dx would be equal to 1, and dx would be equal to du. Now looking back at this relationship, I can go ahead and say x would be equal to u minus 1. So I'm going to write that on the numerator because I do have x in the numerator. So that's u minus 1 over square root of u du. dx is du. Okay, so now there's no quotient rule for derivatives. What we can go ahead and do is we can split the fractions u over square root of u minus 1 over square root of u du, and that would be u 1 minus half, so u to the power half minus u to the power negative half du. Now it's time to perform the integration. So u to the power half, half plus 1 would be u to the power 3 halves divided by 3 halves, which is same thing as multiplying by 2/3, minus u to the power negative 1 half plus 1 would be positive 1 half, and divided by positive 1 half is same thing as multiplying by 2 plus a c. We're not going to leave our final answer in terms of u because we didn't have u's in the problem. Our problem had x's, so we're going to go back and replace every single u by whatever we called u in the beginning. So x plus 1 to the power 3 halves minus 2 x plus 1 to the power 1 half plus a c. All right, next, example number 5. That's also a u substitution problem, but also a trigonometric integral. So quickly, I'm going to remind you that, let me erase this really quick. If you recall, derivative of tangent inverse x is 1 over 1 plus x squared, and integral of 1 over 1 plus x squared dx is tangent inverse x plus c. Tangent inverse x plus c. All right, so here we are for example number 5. First of all, I can see it looks like a tangent, but not really. So what I'm going to do is I'm going to go ahead and factor something out from the denominator. I'm going to factor 9 out from the denominator. So I would be left with 1 over 1 plus 16 over 9 x squared dx, which is 1 over 9, 1 over 1 plus 4 over 3x, everything squared. And we still have dx. So I'm going to replace, let u be 4/3 x, and then du dx will be 4 over 3. Or we can say du is 4 over 3 dx. Or dx is, let's isolate dx over here. Dx is going to be 3/4 du, 3/4 du. So now changing that integral into u integral. So this is going to be dx is 3/4 du. And then we have 1 over 1 plus u squared. Okay. So 3/4 can be pulled out. Du over 1 plus u squared. Almost done. Looks like it's getting to where we want to head over. So this will be 1 over 12, and then integral of du over 1 plus u squared would be tangent inverse u plus a c. 1 over 12 tangent inverse, the u was 4/3 x plus c, and that's going to be our final integral. Let's look at a couple more examples. Here's another one, 1 over 1 minus sine squared theta. So how are we going to do 1 over 1 minus sine squared theta? Well, this is not too bad because cos squared theta d theta. 1 minus sine squared theta is cosine squared theta, and 1 over cosine squared theta is secant squared theta d theta. And is there a function whose derivative is secant squared theta? Well, tangent x. Derivative of tan x is secant square x dx, or it should be tangent theta, not tangent x. So be careful with the angle. Tangent theta plus c. 1 over 1 plus sine squared theta. So how can we evaluate 1 over 1 plus sine squared theta? Let's see. So for 1 over 1 plus sine squared theta, I think I can go ahead and, this one is a more tricky integral. We can go ahead and divide everything by sine squared theta. By sine squared theta or by cos squared theta. Let's go ahead and divide. Rationalizing is not going to help. It's going to give me 1 minus sine to the 4th theta, and that's not going to take me anywhere. So let's go ahead and divide numerator and denominator with cos squared theta. Divide numerator and denominator by cos squared theta. So that will leave me with 1 over cos squared theta over 1 over cos squared theta plus sine squared theta over cos squared theta is tangent squared theta d theta. And that becomes secant squared theta over secant squared theta plus tangent squared theta d theta. Okay. Now we can replace the secant squared theta by 1 plus tan squared theta, which will be 1 plus tan squared theta is, let's see, 1 plus tan squared theta. So this becomes secant squared theta over 1 plus 2 tangent squared theta, because I'll have tan squared theta plus tan squared theta d theta. And now we can go ahead and let square root of 2 1 plus 2 tan squared theta. So we can let the square root of 2 tan theta be u. This is going to be another trig substitution here. So we can let 2 tan theta be u, and then du d theta will be 2 secant squared theta. Okay, 2 secant squared theta. That would be du d theta. 2 secant squared theta. 2 secant squared theta d theta will be du. So this integral, I'm going to need more space. I'm going to erase this and take it from here. My numerator becomes du. I can say secant squared theta d theta is 1/2 du, so I can pull the 1/2 out. And in the denominator, I have 1 plus 2 tan theta is what we call u. Actually, this would be square root of 2. So square root of 2 tan theta would be u, square root of 2 here, and square root of 2 here, and square root of 2, square root of 2. All right, now everything looks good. So now we have this integral becomes 1 over 1 plus du over 1 plus u squared, which is going to be tangent inverse u plus c, 1 over square root of 2, and tangent inverse u is going to be tan inverse of root 2 tangent theta plus c. Okay, that's what our final answer is. This was a pretty tricky integral. Rationalizing is not going to help here, so we can divide numerator and denominator by cos squared theta, and then do some trig substitution over here. We could think of this as a perfect square by writing it as root 2 tangent theta. That would be, if we square it, we would get 2 tan squared theta. And then we did the trig substitution or trig integral over there. See another example. We have e to the power t over e to the power 2t plus 2 e to the power t plus 1. This one again, if you call the whole denominator as u, it's not going to take us anywhere. It's going to be tricky. But if you look carefully, there is something special about the denominator. Denominator is a perfect square trinomial, perfect square trinomial. If I square e to the power t plus 1, everything squared, if I open this binomial, I would be getting e to the power 2t plus 2 e to the power t plus 1. Now it's a lot nicer integral. I can go ahead and let e to the power t plus 1 as u, e to the power t dt will be du. So this integral becomes du over, and we call e to the power t plus 1, so that's u squared, which is u to the power negative 2 du, which is u to the power negative 2 plus 1 is negative 1 divided by negative 1 plus a c. And we're going to replace the u by e to the power t plus 1 plus c. Okay, yep, that's what we would be left with. Actually, it is raised to the power negative 1 also, so don't forget that. If you want, you can write it as 1 over e to the power t plus 1 plus c. That's fine. Both of these answers are good. Right, another example. Now we'll take a look at an example where we have where we do have definite integral. So here's one example we can take a look at. Let's start by, we don't have, what's the derivative of 2x minus 1? Well, that would be just 1, and that's what we have sitting outside. So I'm going to let u be square root of 2x minus 1 du d up. I apologize, not the square root, just 2x minus 1 be the u. That's what's gonna work out. If you call square root of 2x minus 1 as u, you're gonna be stuck and it would not work out. So du dx would be 2. Okay, or we can say du, or 1/2 du is equal to dx. So now I'm gonna write this integral into the u integral. So going from du, dx is 1/2 of du, and we have square root of u. We also want to take care of the bounds. When x is 1, what is u going to equal? So when x is 1, u is going to equal, I'm going to plug the 1 in here. 2 times 1 is 2 minus 1. U will be equal to 1. When x is 5, u would be equal to 2 times 5 minus 1, which is 10 minus 1 is 9. All right, so we are pretty close now. The integral, when we evaluate the integral, this would be u to the power 1/2, which is going to be u to the power 3/2 divided by 3/2, same thing as multiplying by 2/3, 1 to 9. No need to add a c here because this is a definite integral. We have the bounds, so there's no c in the definite integral. Here we are, 1/2 was kept outside. We have 2 times 9 to the power 3/2 minus 2/3, 1 to the power 3/2. All right, simplifying it a bit, this is going to leave me with 2/3 times square root of 9 is 3, and 3 to the 3rd power is 27 minus 2/3. So 1/2, 27 times 2 is 54 minus 2 over 3. 54 minus 2 is 52 over 3. And that's going to be, we can cancel to 26. So 26 over 3 is what we're left with when we evaluate this integral. And there isn't anything more we can do. That's going to be our end product. Okay, and that's all for u sub examples. And these two, I'm going to quickly help you get started. So we will let 2x plus 1 be u, and du dx will be 2. So we can say dx is 1/2 du. And the outside x we can rewrite it. The outside x will be equal to u minus 1 divided by 2. So this integral will become u minus 1 divided by 2 times square root of u du 1/2. And then from here we can simplify. Just distribute the root u inside and then just separate the pieces. Next we have definite integral. X squared plus 3 will be u here, and 2x squared dx, or 2x squared dx would be equal to du. I don't need 2x squared. I do have x to the third over there. So what we can do here is, let's see. So what I'm going to do is, nope, there, that's not right. If x squared plus 3 is u, then 2x dx is du. Okay, or we can say x dx will be du 1/2 du. All right, so let's see. We can, we need to be clever here. We can break this x to the third into x squared times x dx over x squared plus 3 to the 5th power dx, and then there's bound from 0 to 1. All right, I'm ready to change it to a u integral now. When I'm ready to write it as a u integral, this, I put 2 dx's here. That was not correct. This x dx is equal to 1/2 du. And from here, I can say x is u minus 3. So x squared can be written as u minus 3. The denominator is u to the 5th power. At this point, it's really not a bad problem. We can separate u over u to the 5th minus 3 over, excuse me, minus 3 over u to the 5th du, and just simplify the integral from here. It should be a piece of cake. Simplify the powers of u here, 1/2. So u to the power negative 4 minus 3u to the power negative 5 du, and then perform the integration. That would be all for this video.